Alright, sorry for the rain sound. I hope you can still hear me. I'll try to speak a bit louder. So basically for this question, this is another potential evaluation question. So you need to be able to know what is the evaluate. You have to be able to know and evaluate what is the potential is on each part of the circuit. So let's look at the question. The question here says that when the circuit is working correctly, there is a voltmeter reading, right, when the switch is closed. So now let's pretend the switch is closed and the circuit is working properly. So when the circuit is working properly, that means the fuse does not blow, yeah? So the fuse stays intact and it just acts like a regular wire. So let's evaluate what's going on with the potential in the circuit. So first, let's figure out what is the potential here at the source. Let's start there. It's the easiest place to start. Okay, so this is the positive end of the terminal. That means the potential there is 110. So it will remain 110, 110, 110, 110, 110, 110, 110 until it reaches the fuse. Remember, the fuse is not blown, right? If the fuse is not blown, that means it will just act as a regular wire. It will not take any potential from the battery. So it will just keep going at 110, 110, 110. So this will be 110 volt. This also be 110 volt. Again, the switch is working properly. 110 volt, 110 volt, 110 volt, 110 volt. And then at this point, which is point C1, right, the potential will be 110 volt. Right? And then of course, the heater will take, because the heater is the only component in the circuit, that means this heater will take all of the voltage. So this heater acts like a resistance, right? It will take all of the voltage that is given by the power supply. So that means if this is 110 volts, this potential will be 0 volts, right? Because the heater acts like a resistance and it's the only component in the circuit. That means it will eat all the potential difference, all the voltage from the power supply. So that means this potential will be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That means at S negative, the potential difference is also 0 volts. So that means I can conclude that the reading of the voltmeter that is connected to S negative and C1 will be 110 volts. So that means V, when the circuit is working correctly, is 110 volts. Now the question is, what happens if the circuit is not working correctly, right? That means that it's at fault. And the question is asking that which fault, where in the circuit will it go wrong, that will also give the same reading of 110 volts. Okay, so let's evaluate the options one by one. I'm going to start with D. Okay, so in option D, okay, when there is a short circuit, remember guys, if there is a short circuit, the fuse will blow. Yeah? The fuse will blow. And if the fuse blows, okay, if the fuse blows or melted, there will be no current flowing, right? The current will stop at the fuse. So after the fuse, the potential will be 0. And therefore, this potential will also be 0, and then the reading will also be 0. So the reading will be 0 volts. Yeah, because the fuse blows, that means the current stops flowing here, right? That means this potential here will be 0, and therefore C1 potential will also be 0, and therefore the potential difference between C1 and S negative will also be 0 volts. Okay, this also goes the same with option C. Yeah, same with option C. If the fuse melted, it's the same case. This will be 0 volts potential, this will be 0 volt potential, and there will be no potential difference between C1 and S negative. Okay. Now, what if there is a broken switch? If there is a broken switch, okay, so B, if there is a broken switch, that means the current will flow over the fuse and then the current will stop here because the switch will not work, right? And therefore, the potential here, because the current stops flowing here, the potential here will be 0 volts. That means at C1 it will also be 0 volts, and then there will be no potential difference between C1 and S negative. So again, the potential difference here will be 0 volts. Okay? Now, miss, what happened for A then? What if there is only a break in the wire? What if the break happens in the heater? If the break happens in the heater, what will happen is current will still flow all the way. Potential will still exist from here to here, over the switch to here. So even though the break is here, the potential here will still be 110. Okay? Even though there is no current flowing, yeah? Even though there is no current flowing, this will still have a potential of 110. Yeah? If the current is able to flow, it will flow all the way until here, right? So therefore, C1 will still have the potential of 110. So even though there is no current flowing here anymore, or if the heater doesn't work properly for whatever reason, this will still be 110, and then of course the negative side of the battery will have 0 volts. And therefore the potential difference between C1 and S negative will be, for the case of A, will still be 110 volts. Because the potential here can still be 110 volts. While in the previous case of B, C, and D, the current was stopped before it reaches C1. So the potential at C1 will be 0 for the case of B, C, and D. But for the case of A, the potential at C1 is still at 110 volts. I hope that is clear. If it's not clear, please let me know in class.